is section 11.2. Compound interest looks a little differently. Simple interest is usually used for loans of a year or less, but for more than a year we use compound interest, so that means that we earn interest on the interest. Let's work example 11.2.1, calculating future value. We're going to assume that we're doing simple interest, so that means that R is 0.06, and then if it's simple we assume it's yearly, so that means our 6-month period is half a year, or 6/12 of a year, and our P is still 500. So when we plug this in we get 500 times 1 plus 0.06 times half, so we get 515. And then when we do the second part, the next 6 months, now our P is 515, our R is still 0.06. We're doing simple interest, so we assume that's yearly. So that means our T is 6 months, or 6/12 of a year, which is the same as half a year. We get 530 and 45 cents. Alternatively, we can use the compound interest formula, so A equals P times 1 plus R over N to the NT, so N times T is in the parentheses. So N is how many times a year that we compound it, and T is in years again, just like before. So let's go ahead and look at an example. We're going to work the same problem, 11.2.1, but this time we're going to use the compound interest formula. So P is going to be our initial amount, 500. R is still 0.06, again that's semi-annually. T here is in years, so it's 1, and then N would be 2 times a year, because it's every 6 months. So then when we plug this in for A, using our compound interest formula, we get 500 times 1 plus 0.06 over 2 to the 2 times 1. And I'm going to show you how to plug that in on a scientific calculator. So on our scientific calculator we get 500 times 1 plus 0.06 divided by 2. So that's what's in the parentheses, and then I'm going to use the caret. And then parentheses again, 2 times 1, because that whole thing is in my parentheses, and I get 530.45. Let's do it again so you can see how this works. So this time we're going to calculate when we have 10,000 deposited, so that's our P, and an account earning 8% interest, so R is 0.08, and then that's compounded quarterly. Okay. Quarterly means 4 times a year, every 3 months. Okay, T is 4 years, and our N is 4 times a year. So plugging this in, we get 10,000 times 1 plus 0.08 over N, which was 4, times 4. So our exponent here is really 16. We get 13,727 and 86 cents, because we get 0.857 here, and the 7 tells us to round up. We can rearrange the equation A equals P times 1 plus R to the N to the NT to solve for P by dividing both sides by 1 plus R over N to the NT. So it can look like those two equations below, right here, where we divide by that piece, or right here, because when we divide by something, it's the same thing as having a negative exponent. You may have seen this before, that some base to the negative n is equal to 1 over that base to the n. So that's all we're essentially doing here. Let's look at an example of this. So let's look at this example, 11.2.3. How much money should be invested in an account that earns 8% interest? So we know R is 0.08. It's compounded quarterly. So that means we're doing it 4 times a year. in order to have $30,000 in 5 years. So we have T is 5 years, and our A is $30,000, right? Now when you think about this number, it should be less because we're investing and then we're letting the money grow. So we want to make sure that our answer is less. So if our answer is not less, that means we did not use the right formula. Okay, so we have P equals 30,000 over 1 plus 0.08 over 4 to the 5 times 4. So I'm going to show you how to plug this in on my graphing calculator first, just because we can see everything at once. Okay, now you could do the same keystrokes on the scientific calculator. So you do your 30,000 and then divide by, and then I just do a big set of parentheses for my entire bottom, and then we're going to do another set of parentheses for my 1 plus 0.08 over 4. Right now it seems redundant, but we'll need it later. So again, 5 times 4 is in the exponent, so I want to make sure that those are in their own set of parentheses. When we do that, we get 20,189 and 13 with the 9 repeating. Round to the nearest penny. The 9 tells us to go up, so 20,189 and 14 cents. Another place that compound interest is used is when we're trying to determine inflation or use inflation. So inflation is an economic condition where there's an increase in the cost of goods and services. So this happens every day. Inflation is expressed as a percent. We use the same procedure from calculating the compound amount. So there's an example in 11.2.4 that you can do on your own, where we're given the P and then we're calculating the future value. We've already done 2 examples of that, so we're not going to do that one together. But the big idea here is that we're going to use annual compounding to solve inflation problems. So that means that n equals 1. So let's work one where we have to find the present value. So we're going to do 11.2.5, this example. So again, we're calculating the effective inflation on purchasing power. In the quiz, you'll have to do it on salary. So you can work out example 11.2.4 and then check your answer in the book or in the professor's notes. So here we have an insurance policy that we buy in 2015, and it provides us with $250,000 when we retire in 2050. We're assuming an annual inflation rate of 8%, and we want to know how much do we have to pay for this now. That's what they mean by purchasing power. How much do we have to pay for this now? A is $250,000. R would be 0.08%. Again, that's yearly. T is 35 years, so we just plug everything right into our formula. 250,000 times 1 plus 0.08 over 1 to the 1 times 35, and again that exponent's negative. Last time we divided, this time we're doing a negative exponent, so that's a little bit different here, but that way you can see how both formulas are used. And again, I'm just going to use my TA83 just so you can see everything at once, because in a science, depending on the scientific calculator, we don't get that advantage. But you could use a scientific calculator, or again enter all of this in Google if you don't have one. So we have the to the button, and then we need to use the negative button. I'll show you those here in a minute. So in our problem we get $16,908.63. Looking at the 3, 5 tells us to round up, so $16,908.64. So I just want to show you the buttons on the calculator here. So when I raise something to a power, I'm using this button. It means to the power of. It's called a caret. And then when I use the negative sign, I use this button down here, because this one is minus. These are the 4 arithmetic functions, and I'm using the negative button. So they're in different positions, but again, you could divide and you get the same answer. The next problem we're going to talk about is the effective interest rate. Now, a lot of times what you do when you're shopping for a loan or a savings account is you need to figure out which one is going to get you the most money. So when you do that, you need something called the effective interest rate. Now, there's a couple different ways to find the effective interest rate. The one that we're going to look at is kind of the more straightforward way. We're just going to see what it does with $100. So you could calculate both of them with your compound interest for so many years. Keep everything the same. The only thing that changes is your interest rate and maybe n times a year. Because 5% at 4 times a year is going to have a different amount of money than 5% at, say, 12 times a year or once a year. They're all going to be different values. So a great way to do that is just to see what it does with $100. So let's look at an example. A credit union offers a certificate of deposit on an annual interest rate of 3% compounded monthly. So we know R is 0.03, and that's monthly, so we get 12 times a year. We want to find the effective interest rate, and we're going to round it to the nearest 100%. So we're going to use P as 100 and see what it does with $100. So plugging this in, our formula is 100 times 1 plus 0.03 over 12 to the 12 times 1, so 12, and we get $103.41. Looking at the 4, the 1 tells us to leave it be, so 103.04 cents. This would be our amount in a year. So then the interest would just be this minus 100. So we get $3.04 would be the amount we earn on $100, which means that our effective interest rate is 3.04%. Now again, we can do this different ways. There is another way to calculate the effective interest rate in your textbook. I'm going to leave you to read that one on your own.